In this video, we are going to simplify, we are asked to simplify this expression, which is the division. There is a division here of two rational expressions containing exponents. So let's go here and put the rules as we use them. Now the first rule we are going to use is that if we have a divided a over b divided by c over d, the division can be written as a multiplication by the reciprocal. This comes from the rules of fractions, which we can use here. So the first thing we are going to do is to rewrite the expression 3x2y2 and then the division becomes a multiplication, but with the reciprocal. What do you do with the reciprocal? For a fraction, you just flip the denominator and numerator. Now, as it is written in this way, we cannot make any simplifications. So we need to go for the next rule. Now the next rule is a rule of exponent. If you have got a multiplied by c multiplied by d and so on to the power n, this can be split as a power n, b power n, c power n. So you split the, it's like distributing the power for all the terms that are inside the brackets. So let's go and do it here for the first expression. So we have 3 power 2 x2 power 2 and y2 power 2. This is a, b, c, and then the power. This is what I did. 3 to the power 2, x2 to the power 2, y2 to the power 2. Now let's go down and do the same thing. So here we will have minus 2 or negative 2 power 4, x power 4, y2 power 4. Let's go here and do the same. So this is what I did, a, b, c, and then I split with the power 4 everywhere. Same thing, I'm going to do it here as well. So it will be 6 power 2, x minus 1 power 2, y power 2, everything to the power 2. Good, and I will go here, and this is my a, b, c, and I do the same thing. So 3 power 3, x power 3, and y power 3. Now the next rule I am going to use is if I have x to the power n, everything to the power m, that gives me x to the power n multiply m. Multiply. So let's go to our expression and start applying it and simplifying. Now 3 power 2, it's a 3 times 3, that gives me 9. Now x to the power 2 to the power 2, so I apply this. So it's x to the power 2 times 2, that's an x4. Y to the power 2 to the power 2, I apply the same rule. I multiply 2 by 2, that gives me y4. Now let's go here. Negative 2 to the power 4. Negative 2 to the power 4. That gives me 16. X to the power 4. That stays x to the power 4. Y power 2 power 4. This is the rule I'm going to use. 2 times 4, 8. So y to the power 8. Multiply. Let's go to the next expression. 6 to the power 2, that's 36. Now x to the power minus 1 to the power 2, I apply this. So I multiply minus 1 by 2, that gives me negative 2. And then this one as well, I apply the same rule. and that gives me y to the power 2 by 2, that gives me 4. Let's go down here, 3 to the power 3, that's 3 times 3 times 3, that gives me 27, x3 and y3. The next rule I am going to use is the multiplying monomial. So let's assume I have got a monomial with a as a constant, and for example x2y multiplied by another polynomial b constant and xy3. This is an example. I'm explaining this rule by an example. You multiply the coefficient ab, you multiply the variables with the same letter x2 and x, and you multiply the again with the same letter y and y3, and then you simplify. So let's go here and apply it. I have a constant 9, 36, 9 times 36, x4, x minus 2, x4, x minus 2, y4, y4. Okay, what I did is constant with constant here. The x's together, x4 and x minus 2, and the y's together here. Now let's do the same thing in the denominator. I have got 16 and 27 together. I have got x4 and x3 together. And y8 multiplied by y3. This is an 8. So what I did here, constant with constant, the x's together, I am multiplying, and the y's together, I am multiplying. Now the next rule I am going to use is the following. If I have x to the power m multiplied by x to the power n, that will give me x to the power m plus n. So exponent with the same base, you multiply them, and the exponent is the sum. So let's apply the rule. Now let's keep the constant as they are for the time being, because there might be some simplification. So I'm going to apply this rule here. This is x to the power 4 times x to the power negative 2. It will be x to the power 4 minus 2. And that gives me an x2. Here, y to the power 4 times y to the power 4. 4 and 4 gives me 8. Y to the power 8. Okay, we go down. Let's keep the constant as they are. And then I apply the same rule here. Same base x, the exponent will add, so x to the power 7, 4 plus 3, and then the term y8 plus 3, so y, okay, same base, I can apply 8 plus 3, 11. Now the next rule I am going to use, it's a rule of fractions. In fact, I have a times b times c in the numerator multiplied by d multiplied by e multiplied by f in the numerator. This can be written as a over d, b over e, and then c over f. Now let's apply it here. So we're going to have all the constants together. x2 over x7, y8 over y11. And start simplifying. Now let's simplify the constant term. I prefer to do it by hand. 9, 36, 16, 27. Now 27 is 3 times 9. 36 is 4 times 9. So this goes, and they will be substituted. Now we start simplifying, okay? So this 9 goes with this 9. 16 is 4 times 4. So this 4 goes with this 4. We are left with 9 over 12. So all this is 9 over 12. Now, the next rule we are going to use, it's the rule of exponents. X to the power m divided by x to the power n, exponent with the same base. The rule tells me this is x m minus n. M, the power, m is the power of x in the numerator and n is the one in the denominator. So that will give me x to the power 2 minus 7, that gives me minus 5. And here y to the power 8 minus 11, that gives me minus 3. Okay, good. So we're very close now. 9 over 12 can be simplified. Hang on. 9 over 12, we can divide by 3. Divide by 3, divide by 3, 3 over 4 in fact. Okay. Good. Now, we are asked to write all this with positive exponents. Now, positive exponents, x to the power minus m. This is another rule. I think we're at 7. X to the power minus m is 1 over x to the power m. So, positive, it will be 1 over x 5. And this one, 1 over y3. And all this can be written as 3 over x for x5 y3. This is the final expression, the final solution in simplified form, and I don't think we can go any further than this in simplifying.